All right, guys, lesson 90. This is it. This is the last one for the year. You made it. Let's do this.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 90. We're going to solve equations from word problems with two statements of equality, okay? This is the same kind of stuff that we've been doing with coin problems and value problems. Same stuff. Okay, so let's just get into it. Example 1. Together, Charles and Nell picked 92 quarts of berries. Okay, so we can say that right away. We can say Charles plus Nell equals 92. So C would be number of quarts Charles picked, number of quarts that Charles picked, and then N would be number of quarts Nell picked. Okay, so together they picked 92 quarts. That makes sense so far. All right, what's the next sentence? If Charles picked 6 more quarts than Nell, how many quarts did each of them pick? Okay, so now we have another equation. This is also a quantity equation. So this is quantity number 1, but then there's another quantity type equation. So there's no value of each quart or anything like that. So we're saying that Charles, the number of quarts Charles picked was 6 more than Nell's. Okay, so now we have an expression for C that we can plug in right there. So now we're going to rewrite this equation. N plus 6 plus N equals 92. All right. First step to solving equations, simplify both sides, no parentheses, but there are like terms. N and N is 2N plus 6 equals 92. Second step says if you have variables on both sides, get rid of the smaller one. You don't have that, so we're going to move to step 3, which is get rid of constant on variable side. So 2N equals 86, N equals 43, so that's how many quarts Nell picked. So how many did Charles pick? Well, Charles is whatever N is, 43 plus 6, so Charles is 49. Together they picked 92 quarts. That works. All right, let's try another example. Moving right along. Example 2. Number of boys in Sarah's class exceeded the number of girls by 7. So I can say that number of boys is whatever the number of girls is plus 7. So there's 7 more boys. Okay, so that's quantity number 1. Let's see if there's another quantity equation. If there were a total of 29 people, all right, total of 29 people is just B plus G equals 29. So now we have 2 equations with 2 variables. Here's our expression for B. So we're going to plug that in for our B right there. Let's do it. G plus 7 is our new B plus G equals 29. All I did was rewrite this equation. Combine like terms. 2G plus 7 equals 29. Get rid of the constant on the variable side. So 2G equals 22. G equals 11. So if G equals 11, you could plug that in right there, or really any equation, doesn't matter. So number of boys is 11 plus 7. So number of boys is 18. Let's just make sure it's right. Does 18 and 11 added together, does that equal 29? Yes, it does. Boom. Nice. Example 3. We are booking. Here's what it says. Philip cut a 38-meter rope into 2 pieces. The long piece was 9 meters longer than the short piece. Okay, what were the 2 lengths? So we have a long plus a short piece, and together they have to add up to 38 meters. It's a 38-meter rope, right? And we also know that the longer piece was how much more than the short piece? 9 meters longer than the short piece. So does this make sense? Long piece is 9 more than the short piece, and together they equal 38. So press pause, see if you can do this. Do it. Okay, so here's what L is. So I'm going to plug this in for L. So I'm going to say S plus 9 plus S equals 38. So this is still L plus S equals 38. All it is this equation written. Combine like terms, 2S plus 9 equals 38. Get rid of the constant. 2S equals 29. Okay, don't panic. We're gonna have an odd number, but that's okay. You can have a half of a meter, right? So this is just gonna be 14.5 meters, all right? Well, if this is 14.5 meters, L is whatever S is plus 9. So L is 23.5 meters. Okay, that's cool. All right, a couple more and then we're done. Example 4. The sum of two numbers. I'm just gonna say A plus B is 72. See how the sum of two numbers is 72? The difference of the two numbers is 26. So what's the difference? That's subtraction. A minus B is 26. There's two equations. That works. So what method do you think would be best? I mean, you could do substitution if you want, but it's set up so beautifully for elimination. Look, what happens if you add these two equations together? Those guys cancel. So you're left with 2A equals 98. A equals 49. Awesome. So B has to be whatever 49 plus that is. Okay, so let's just plug that in. A plus 49 equals 72. So get rid of 49, get rid of 49. A equals 23. All right, let's make sure that the second equation works. 49 minus 23 is 26. It works. Cool. All right, one more and we're done. All right, example 5 says the greater of two numbers is 16 greater than the smaller. So this is kind of like the long piece of rope and short piece of rope. All right, so let's say the numbers are A and B, okay? So the greater the two numbers, you can either have it be A or B, is 16 greater than the smaller. When added together, their sum is 4 less than 3 times the smaller. What are the numbers? All right, this is kind of different, but all you have to do is translate that into a nice equation, okay? So see if you can do that. Press pause and see if you can do it. Okay, so the greater of two numbers, I'm gonna say A, is 16 greater than the other. That's a direct translation. A is 16 greater than B. All right, when added together, okay, so that's one equation. When added together, okay, A plus B, their sum is 4 less than, remember 4 less than is subtract 4. 4 less than what? 3 times the smaller. Well, the smaller is B. So when added together, A plus B, the result is 4 less than 3 times the smaller. Okay? Now we've got two equations. I'm gonna just plug in my A value right here, 16 plus B, in right there and see what happens. So 16 plus B equals 3B minus 4. All right, combine like terms. There's no parentheses, so simplify both sides separately by just combining like terms here. All right, second step to solving equations is get rid of smaller variable term. If you have variables on both sides, you do. So we're gonna get rid of this 2B because 2B is smaller than 3B. So now we've got 16 equals B minus 4. Third step to solving equations is adding 4 to both sides, or get rid of the constant. So you're gonna add 4 to both sides. B equals 20. So if B equals 20, what does A equal? Well, A equals 16 plus whatever B is, 20. So A equals 36. All right, now let's see if this works in the other equation. When added together, 56, the result is 4 less than 3 times the smallest number. So 3 times the smaller number is 60, right? 3 times 20 is 60. What's 4 less than 60? 56. It works. Boom. Okay, so there is one more example. So let's just do one more example. I know you've lasted this long. It's gonna be great. So One more example. Here we go. This is example 6. There's 6 examples. That's a lot. So the ratio of two numbers is 5 to 4. Okay? And the sum of the numbers is 63. What are the two numbers? Okay, so we could say this. The ratio of two numbers is 5 to 4. Is that weird? Let's go with that, okay? But then the sum of the two numbers is 63. All right, well, let's see if we can simplify this. You know what? The cross products are equal. So we're just gonna turn this into this problem, which is just 4a, 4 times a has to equal 5 times b. All right, so here's one equation, here's another equation. So I think I'll just get rid of b here and get my a by itself, 63 minus b. So this guy's gonna go right there in for a. So let's rewrite that. 4 times a, which is now 63 minus b, equal 5b. All right, distribute that. So we get 252 minus 4b equals 5b. All right. So both sides are simplified. Second step to solving equations is get rid of the smaller variable term. You do have one, that's negative 4b, so add 4b to both sides. So 252 equals 9b. Last step to solving equations is divide by variables coefficient. So b equals 28. Okay, if b equals 28, what's a? Well, 28 plus what equals 63? Well, a has to be 35. Okay, now let's see if it works in the other equation. So is the ratio from a to b 5 to 4? Well, if you reduce this little fraction here, 35 over 28, if you divide both the top and bottom by 7, guess what you get? You get 5/4. Boom. Cool. All right. Does that feel all right? Okay. We just have one more test review and then we're done for the year. So good job, guys. I know it's been a tough year, but I'm so proud of all of you. You're awesome. Way to hang in there. We'll see you in our test review.
Flack math, give me some math and I'll give you some flack.